Hi, Sebastian. I'm Kajal Mehra, and I'm the senior supporter at TimesTech. Currently, I'm at Noida, and I welcome you to India.
Thank you very much. Thank you very much.
Yeah.
So I'm sure the team has already briefed you. I manage. I'm the vice president for sales and marketing, and I take care also of strategy and so what we call tech sales. So it's engineering applications at Dassault Systèmes for SIMULIA.
Great. So we'll move ahead to the Q&A session.
Mm-hmm.
Okay. So my first question for you is that India is witnessing a rise in virtual twinning as a tool for indigenous innovation. How is SIMULIA enabling this trend across sectors like aerospace and defense, transportation, and mobility in high tech?
All right, so that's a pretty vast question, but I'll try to be synthetic around it.
Okay.
So SIMULIA historically has been growing as an addition of different softwares that we've acquired over the last 20 years. And in different fields of engineering. Okay, so it can be in structural fields for vibration or crash worthiness. It can be in electromagnetics for electromagnetic compatibility for phones or for vehicles. It can be fluids for outer skin design for airplanes or cars and so forth. So we have a lot of topics that we cover from an engineering perspective. Okay, and fundamentally, when I look at the Indian market, has evolved quite a bit the last 15 years, being very much historically when we started working, it was a lot of engineering centers for large OEMs abroad, right? Was the major business area for SIMULIA. And I think that we've evolved quite substantially in terms of having our largest customers in India are Indian customers in the transportation mobility area. So the Mahindra and Mahindra or Tata Motors or a number of their suppliers, or in the aerospace with a lot of work that we do with the development labs here in India. Okay, so that fundamentally that change over time corresponds also to an acceleration in technical innovation by Indian companies, all right, which has to many points outpaced acceleration of innovation in other countries, right? So that's why India is such an important market for SIMULIA. Okay, and when we look at evidently each industry that you cited move at different paces. Okay, there are some that are very government regulated, so aerospace, defense, high-end electronics is very much regulated by the government. On the other hand, very privately driven is, of course, all the startup landscape that we have, and then the large T&M or transportation mobility OEMs. So when we think about that acceleration of innovation, fundamentally, one of the key components is acceleration of time to market. All right, so reduction of design time to be able to bring a product between the requirement definition into kind of the architecture definition of the product, into preliminary design, complex detailed design, and then manufacturing, right? So where SIMULIA is very active is on that segment between requirement definition, concept designs, and then detailed design. So detailed design being kind of historically what simulation was used to. And when we think about, okay, that acceleration in innovation has come because we've been able to transfer a lot of the simulation technology into early design. So we call that in the market in terms of product design is called left shifting. So when you think about, I'm guessing a V diagram is meaningful for you, I'm sure. It's you define you have a first section of the design space is on one side of this V, which is defining the requirements and therefore defining the architecture in an initial design. And the other side is that validation that design can actually work. Okay, and that validation can be either through simulation, can be through testing, can be through complete vehicle testing or complete airplane testing. And the end of that cycle is certification. So for anything which is certification driven, so it can be cars that need to be certified for crash. It can be airplanes for flight, for vulnerability, for not falling out of the skies. It can be but it can be also for cell phones, for not emitting too much microwaves. Typically, that would be damageable for your brain every time you call, right? So the certification aspect has been a long target of simulation to try to reduce the number of prototypes you generate for certification. Now, that has evolved a bit, I would say, the last 15 years to have that as a continuous effort, but to bring simulation in the early requirement definition part. So if you can simulate, let's say, a concept of what you want to build as a product, very early, you might recognize that you are generating by design a problem that you would have to fix later on. So when we think about acceleration of innovation, is mostly because you've been able to early in the design phase catch an error or a problem that would be something you could correct later on, but it would be very costly to correct it. So if I take the worst case scenario is you start producing a product and you have to recall the product from the market because you have a problem that has appeared because it's a statistical manufacturing problem, right? And then you have to change all the tooling of your manufacturing, which costs hundreds of millions of dollars to do once you've started production. So the earlier you can catch that defaults, the easier and cost effective it is to change that concept. Okay, sometimes it's things that you can catch only in manufacturing, so be it, but a lot of it, 80% of the costs incurred have been kind of designed into something that worked as a component, but once you put it together into a vehicle or a phone, that you put your PCB into the phone, it reacts to the antenna, it reacts to the GPS antenna, and therefore it doesn't work once it's assembled. So that aspect of trying to bring things together is, I would say, in the early phase to de-risk is, I would say, the largest impact that we can have. Now, when we think about how do we have that impact, all right, as a Dassault Systèmes and not just as SIMULIA, we provide not only the simulation capability, but the modeling capability with our colleagues from the brands CATIA and SolidWorks. And we manage data in a PLM sense, meaning that all of the product lifecycle management with the PLM cycle is that we can trace certification or validation through simulation directly to the model that was used to generate whatever the product is. Okay, and that particular aspect is called the modeling, or sort of mod sim in our company. So it's modeling and simulation. It's what we talk a lot about in the social media and so forth, because that is a key element to be able to upfront simulation early in the design stage.
Great. So
I tried to condense it, but
yes, absolutely, absolutely. So with India's growing reputation as a global emerging hub, how is Simulia supporting large enterprises, MSMEs, and startups to leverage realistic simulation for faster product development?
So, so from a product perspective, okay, we provide the same products to a startup than we would provide to a large enterprise. All right, so the product development, if I just take a second to discuss about what our product offering is, doesn't change between how do we deploy something at a large OEM, rather compared to in terms of the functionalities of the product than what we provide to somebody, a startup that's making a drone, for example. Okay, so because the requirements of the product at the end require the same capabilities. Okay, now how do we support customers to deploy that changes depending on, I would say, the maturity of their organization, the size of their organization, of course. So you would tend to think that large OEMs have the ability to absorb more new technology and new methods quicker than startups or medium-sized companies. The reality is more the opposite, to be honest. If you take a startup that has maybe 15 people designing the product and 2 people doing simulation, or 1 person doing simulation, it is much easier to have a discussion about the engineering process to how to use simulation effectively. than in an organization that has 5,000 designers and 1,000 simulation specialists. All right, so that both of them remain somewhat transformational. So I would say that when we have big deployments on the let's say on the data management side, on the PLM side at Mahindra and Mahindra, for example, there's a whole program to evaluate how to change their process to innovate faster. Okay, so it's very well supported top down inside of the company. Okay, I think that generally speaking, from a management position, there's always a push to transform. You find that in larger organizations, there's a lot more historical process that exists, and people tend to feel secure around historical process and don't want to change. So the cost of change in a large company is higher than in a startup where you just have, fundamentally, you talk to 20 people. If you can articulate the benefit of changing the process, usually people are ready to change. So that in that sense, how do we deploy the different technologies has different time scales between a small company and a large company. That being said, the impact on a very large company is calculated in tens of millions of euros of time savings, or hundreds of millions if you can avoid having a problem with the car that gets recalled. Those impacts are immense. All right, but the cost of change is also larger in large companies. So I think that we have in very large companies, we have typically engagements that are on the transformation of their engineering methods. All right, that's simulating earlier on in the process and so forth. And at the same time, we have a second stream of supporting specialists that do very high-end type of simulations. Now, in smaller companies that are on the high tech part, there are a lot of startups that we work with in electronics and startups or startups in aerospace. They're doing very high-end type of products that require high-end products from a simulation perspective, capabilities altogether. So we have that double track. I would say it's probably easier to have a discussion before you start a program with a startup to say, this is how we could do it and it would save you so much money, rather than a car company that has a legacy of 50 years of building cars the same way that has to evolve over time. Right. So I would say that's kind of the difference. Now, if we ask as a company on the commercial side, evidently we have incentives to support startups. All right. So fundamentally, when we go to market, we have cooperations with startups, and then so commercially speaking, we help them in terms of keeping their budgets reasonable so that they can actually start growing. And therefore, there's a startup support program that exists inside of Dassault Systèmes.
Okay. So, SIMULIA has a long standing legacy in the CAE industry. Could you elaborate on its evolving role within the larger Dassault system ecosystem, especially in today's digitally integrated landscape?
Right. So I think we have we were incorporated as SIMULIA in 2005. Right. A few of the companies that were integrated at the beginning had been around since the 70s. That's in particular the product Abacus for structural mechanics. PowerFlow for the fluids had been around since the early 90s as well as a tool, as independent companies. So I would say, to your question on the evolution in integration, okay, there's a continuous development of the solver capacity. So when you talk about a product, there's the customer interface aspect. There's the solver, is what is the physics that we model, and how do we model it, and how fast is it to get a response. And then there's a last part, which is the overall engineering process integration. So if I try to separate a bit the solver part from the integration aspect, so client interface or user interface and integration into process, there are two streams of development. One is around really solver performance, and that's more than half of our development budget goes into developing better solvers, faster solvers, portability from CPU of GPU and so forth. So those are really core performance topics that are independent if a customer buys an established product standalone or buys something integrated in the platform. All right, the solver part remains exactly the same. That's why it's a mutualized both environments, either legacy or established product environment or platform integrated environment, both call on the same solver. So we have a common singular development of the solver. So to your question on the integration part now, that being said, okay, so a lot of effort goes into the user interface, first of all, on what is the tool that the customer actually looks at on the screen. That's important in our business. First of all, and the second part in the integration in the 3D experience platform, which is the data backbone of Dassault Systèmes. A lot of our work goes into not just integrating so that you have a button to push to start the program, but to develop workflows for each industry that correspond to what our customers need. Okay, so when we say that we do an integration in the 3D experience platform, it's because we're developing a role that's based on whatever initial product, but that is following a type of usage that is tailored for a structural engineer in automotive, a structural role in aerospace, an electromagnetic specialist for antennas, an electromagnetic role for EMC. So I think that we try to specialize so that we go away from having products that do everything to a more segmented industry-based focus integration. And that integration allows us to do the ModSim that I was talking about previously, which is to be able to link through the integration the simulation model directly to the CAD model that we would be provided from. And it's mostly CATIA or SolidWorks, but it can also be through an API, through a connector. It could also be data coming from Siemens NX or PTC Creo or whatever. So we have modules to import other format sources. Again, that being said, a lot of what we do that is really streamlined and integrated is with CATIA and SolidWorks.
Okay. ModSim, it is being called a game changer for engineering. Why is transitioning to a unified modeling and simulation platform so crucial? And how does it benefit organizations operationally and competitively?
Okay, so what I was trying to explain before is that when you integrate a product into the platform, you access the platform works as a data-centric data management system. Okay, and that data centricity has a part which is the 3D representation of the CAD, has a part that is all of the metadata that's associated with the part. It has an attribute which could be simulation, which is attached to that data. So whenever you run a simulation inside of the platform that is directly linked to CATIA, for example, you pull the data with traceability inside of the system to your simulation. So you can know exactly from your simulation what part of the CAD was used to run the simulation. And that's very often a challenge in larger organizations, that you have somebody working on a CAD product and you have a disconnected simulation. So somebody has to export a usable format, all right, without going into detail, and you lose that connectivity of that format to the original CAD. All right, and ModSim takes that step away of being able. Technically, it happens behind the curtain, right? But it's technically you're bringing that data that you're applying your meshing, your boundary conditions, your simulation on inside of the same data set. So that connectivity happens at is seamless, right, between both of them. So what we do, because nothing happens for free, all right, is that we develop all that pre-processing. So taking the CAD to go into simulation, and we can automate it inside of the platform so that the user that's actually running it just sees that he's pulling one data into the simulation. Behind the curtain, the preparation is happening and it starts the simulation. So the automation is the crucial part that is done by CAE analysts, is how to prepare a simulation independently if it's in or not in the platform. And how do you embed that preparation as kind of a loop, right? So that afterwards, if you change something in the CAD, you can rerun the process and get a result again on an updated CAD. So that is where the major gain from an industrial process comes, that you do not have to export, send it to somebody by email or per FTP. Somebody needs to work on it, sends you back a result, then you have to rework on your CAD, you re-export your CAD, and so forth. So that very sequential kind of traditional way of doing things, it's not unfeasible, right? You can Python script it as well, right? That's if we're realistic. It's not like nothing can be done, but that seamless traceability gets lost every time you do an export. All right, so I export, it becomes a dead, what we really call a dead object, because you cannot modify that object once it's been exported. The links to how it was parameterized before in the design cycle for the real mechanical or electromagnetic design is lost once you export a surface to do a simulation. Okay, so that's where the real time game is that if you change something on the design because you say, okay, this doesn't work, I have a KPI in terms of performance that's not met, I'll take something that's not mechanical to change a little bit. I say the aerodynamics of the car makes that you have too much lift, so the car is going to be unstable. All right, I can go change the shape of the rear end of the car to improve stability. I change that geometry and I just rerun the process automatically. All right, and then I get an answer 24 hours later instead of having to wait 3 weeks that somebody meshes it and restarts it and all that circuit. So that's where the competitive gains of ModSim in terms of I would put it first in terms of efficiency, engineering efficiency, are calculated by our customers. So if our customers can say, and we had some examples that we could cite because they talked about it at a conference. There's a tier 1 supplier in Germany, that Continental, that provides brake systems to all the auto car makers. Right? They use the system so that their designers can run hundreds of simulations, and they've brought down that simulation cycle from somewhere around 30 days per cycle to 6 hours. All right, meaning that a singular designer can do multiple designs, run it overnight, and the next day can choose which is the right design instead of running a design, waiting 4 weeks, getting an answer back and saying, oh, I need to change my design. So that has improved their time to market greatly, right? Or the other way to look at it is that it gives you the opportunity in the same time of 30 days to do so many more optimization of that to reduce cost, reduce weight, reduce whatever the target was that you want to reduce, right? So it's usually we always talk about, okay, we can get a lot shorter because that's the main, let's say, measurement today in the automotive that we try to reduce from 4 years to 2 years, 2 years to 1.5 to 1 year for a design for a complete vehicle. That time constraint is huge in the transportation market, right? Airplanes, the same thing. We've gone down from 15 years to 10 years 10 years ago, and we're trying to crunch it now in 5 years. Probably the next generation of an Airbus A350 will have to be done in 3 years. Same thing goes for engines for airplanes and so forth. So that time constraint is huge. That being said, the trend that any simulation person does is if everything takes shorter time, I run more simulations to try more variants, right? It's something that it's a natural effect. So we haven't seen a reduction of number of simulations through it, but much more for a given time frame, people do a lot more testing that they wouldn't do otherwise. And that really feeds into the early stage detection of faults in systems. So if you can really detect, because you're able to do 100 simulations instead of 2, you've tried all these different options, and the options can be not the shape, but it can be the environment of the usage. So you can really find out much quicker if there's going to be a problem somewhere down the line, which is where the real money is spent. All right. Any delay, and you'd have to interview people at Mahindra or Tata about this, but any delay of a week of production because there's a problem and the production line doesn't bring hundreds of cars out per day is costs in hundreds of millions of euros a week. All right. So that's where the real, and so therefore your investment on IT and software, if you can detect that, is nothing. It's marginal, right? So that's where we're trying to move our customers in that direction. I guess so that's really from a ModSim perspective. That's what ModSim enables companies. And I think that if you talk to an aerospace company or a defense company, probably the focus is more on the traceability. Because there's the regulatory requirements in terms of traceability that are much higher in space or aircraft design. and then defense is even on top of that. Whereas automotive is interested by the traceability because it shortens the development time. All right, so it's maybe the KPIs might vary a bit on why people want to do it, but we see it across the board. So if I think we have some high-tech manufacturers that do phones, one of the major criteria for acceptance of a phone is the so-called drop test. All right, it's how often can you drop your iPhone or your Samsung Galaxy or your Xiaomi, whatever it is, how often can you drop it before the screen stops working? Right, and there are metrics to be able to simulate. So we do that with Abacus as a tool coupled to CST for the electromagnetics. And so without it being fundamentally a topic that is, would they not come out with a phone, because they need to come out with the new phones every 6 months, right? That's the timing in that industry, right? It's every 6 months you have to have an update of the phone. So the time constraint to make sure that you're not building something that's going to break becomes immense. And we have customers that run tens of thousands of simulations per month because they drop the phone straight, they drop it sideways, they drop it while they're walking, they drop it on 1,000 different surfaces. So the ability to automate that process of dropping the phone and changing the environment around it allows them to try every single configuration and drop it 1,000 times in a row and see what the defects are on the phone. So that's the level of precision and trust people have in simulation, is that they really trust that as a KPI to say, okay, I can bring a phone out on the market or not.
Okay. Can you share some real world success stories where customers have significantly improved outcomes through the adoption of the ModSim approach on the 3D experience platform?
Sure. I think that we have many customers that are doing it. There are a few that I can reference because they've published articles with naming us as public references. Here in India, very clearly, Mahindra and Mahindra have been implementing the platform for about 2 years now, I believe, and have seriously cut down on development time based on the simulation coupling in ModSim. So that's one customer that's been vocal, and I think that there's probably a customer reference on our internet site where they talk about it. So they have been able to. It's never just one silver bullet, right, to reduce the development time, but it's a major game changer for them in terms of shortening the process time to run simulation. And therefore they run a lot more in early stage, and therefore they were able to skip over some of the validation stages that they would have waited to have a prototype. So they would have waited 1.5 years to get a prototype to be able to run it. That they've been able to do in the first 8 months of the product program development. So Mahindra is a good one. Boeing has been using the platform as an early adopter for now 12 years, I believe, and they use it in terms of for composite design, for overall crash design of the aircraft. We had an example once at a conference of Airbus, the same way. That is a very big platform user that they do barrel drop. So you take the fuselage, and there's a certification measure that you have to drop it, and it can't crush more than the luggage if it falls on the tummy. And typically that they use, and they talked about speed ups of 1 year in overall product development for an aircraft, right? So it's 1 year out of 7, right? So just to give you a kind of a focus, same way, Renault, as a French auto car maker, spoke out to acceleration of reduction of 4 years to 2 years of their development process, because they have a digitalization process that covers not just simulation, but also manufacturing management and so forth. But they all come back into the same data management system. All right. So if you're able to go from your CAD to your manufacturing, and go from your CAD to your simulation, and simulation in manufacturing, those are all areas where there's incremental speed ups everywhere that happen. Okay. So I think those are kind of the big ones. Maybe on a different note, that have talked in conferences, or PepsiCo would be the same in the US.
Okay. So with AI increasingly becoming a driver of innovation, how is SIMULIA integrating AI-enhanced capabilities into ModSim, and what impact is this having on design, decision-making, and simulation workflows?
All right. So AI is a very vast topic, right? So when we talk about AI, it covers many, many areas of our product development. It has an impact in terms of the user interface. All right. Do you prompt your program to use something that would resemble, or it's a large language model approach that you would prompt it, you type in, or you talk to your computer and say, I want to set up a simulation for crushing a bottle. Right? And the system will provide you an answer, a text answer of saying, all right, to do a top loading case, which is the engineering name for this, this is how you would set up your model. This is the requirements on the mesh. And so that goes and interrogates the AI behind the scenes, or interrogates your database of knowledge, or all of your documentation and so forth. So there's a documentation aspect in terms of helping. So it's technically kind of like copilots that you would see if you use Windows. That you, if you do Microsoft Copilot, you say you ask for something and it's going to tell you how to do it in Excel or whatever, right? So there's that aspect of user interface, which is something. There's the aspect of how do we impact simulation time in itself. So that's the machine learning aspect of, which is covered by, I guess the technology, underlying technology is surrogate models, as it's called. So people talk about AI or talk about machine learning for physics, but it's how do we generate through machine learning 1D surrogate models instead of doing 3D simulations. So when the usage that we see of AI, all right, first of all, I think that there's a statement that should be made that AI is a great concept, but it's not a silver bullet for everything. All right, so we need to differentiate when we go to market in an industrial environment. So not a personal usage of ChatGPT. Of when you go into an industrial, it has to have an impact that accelerates the development cycle. All right. So what we do as kind of a preamble to everything that we do is we work on methods that are related to workflows that our customers are using. All right. So that kind of sets the stage to say that we work on the surrogate modeling topic, not in a very broad band. Here's a tool, you can do surrogate models out of it. It's very much we work on specific topics that our customers are usually already addressing through ModSim. So it can be structural mechanics, it can be fluid mechanics or electromagnetics or multi-bodies or whatever the end product is. But we work on bringing AI or surrogate models into the usage scope of the designers. So when we think about, maybe just coming back to the discussion around ModSim, because we see it as an extension of ModSim. When we think about how do we do left shifting in simulation with ModSim, is that we have a simulation specialist or an analyst providing a method to a designer so that the designer can do it quickly. Right? There's a risk associated to that in terms of knowledge of simulation, that a designer could always change the template somehow and therefore generate simulation without being a simulation specialist. And that meets a lot of resistance in large companies of analysts that say, no, I don't trust a designer. They'll say it in more polite ways, but it's technically what it boils down to is a question of trust, because there's been so much work put into building validation of simulation so that people trust the result, that you can break that trust very quickly if you simulate something that is wrong. And it's easier to simulate something wrong than simulate something right. So people develop methodologies that are very, let's say, coercive in terms of the usage, so that people always simulate the same way so that they can ensure that the quality of the statement that they make at the end of the simulation is correct. When we talk about using surrogate models for designers, that means that a specialist can build through machine learning a surrogate model that would replace the simulation part of ModSim in terms of the real simulation algorithms and solvers, replace that by a black box that he has defined in the framework where it works. All right, so he can say, you can use this model inside of this framework. Right? If you go outside of the boundaries, the model might not work. So don't use it outside. So it becomes the responsibility of the CAE analyst or specialist to define what that AI model, the validity of the model is, and then they provide a black box that a designer can use. Now, when we think about some of the difficulties for designers to use ModSim, is that if you're a designer changing your CAD, right? You want to be able to press on a button and get a simulation result of that CAD, and you want to get it relatively fast. So if the mod sim process, even if it's highly automated, takes an hour and a half to get you a result, that's longer than a lunch break. So people tend to say, all right, I only do it if I'm pretty mature on it, right? Whereas if you can get in 1 second a response from an AI model built on the mod sim simulations, then that becomes something that can be widespread used by the designer. So that limit or limitation that we see on designer usage of simulation due to, one, the risk associated with not doing it right, two, the time to actually get a result. The time to get the result is the area that the designer is going to see that's going to make a change. So we really believe that the adoption of those types of technologies are going to increase dramatically the number of simulations a designer is going to run on while he's developing his concept. All right, so we're going to get more and more simulation-driven design by designers, whereas it was usually something that people were dreaming about for the past 15 years, but we never really got over the, let's say, the hump of having to get, one, that trust, and two, that time to get to it. So that's where, so to answer your question now more precisely, what we're working on very much is the AI models that are underlining in these surrogate models. That's a whole science in itself. So, okay, so we have a large team that's working on that. And there's a second team that's working on how do we implement that in the 3D Experience platform so that a CATIA user or a SolidWorks user, or by all means, any other CAD user that plugs into the platform can use that methodology on his CAD. So he can be in his CAD and press a button in the platform and get an instant response or quasi-instant response. So, and that's a whole part of another part of the software development on that integration. The feedback that we've had by talking to most of the OEMs who are the most advanced in using AI methods is that they've spent the last couple of years doing a lot of evaluation of the technology. And the evaluation of the technology is in the sense of, how precise is it, or how accurate is a result coming out of an AI model? And that fluctuates depending on the complexity of the problem that you have at hand. All right. So there's been a lot of evaluation. I have not yet met a customer that really uses it productively. All right. So we're still kind of in the finding phase of how can that technology really help us? What are the topics? So we've been very active in bilateral work with customers and with the Indian customers as well. So because part of that team that's working on it is based in Pune. So we've had a lot of work with Indian customers, kind of as early adopters or testers of that. And based on the feedback the last 18 months, we've modified some of the topics that we're working on. All right, because those are the high value topics for those customers. So the customers that we've touched, we've done about, I think it's fair to say we've done about 70 proof of concepts with customers in all different types of areas now, or industries. And we're kind of zeroing in terms of the product releases on the areas that have really the biggest chance or the biggest engagements from OEMs or large manufacturers to really deploy at a large scale. Okay, so I think that if we think in the future, instead of having a kind of a ratio in a company, and a car company might be that you have 5,000 people doing mechanical design and you have 700 people doing simulation for all types of simulations. Fundamentally, what the car makers want is that those 5,000 people that do design are able to at least de-risk the early stages of their design themselves. So what the reality nevertheless is, and I think that we need to be realistic about it, is that AI will never replace completely 3D simulation, the same way 3D simulation doesn't completely replace, on critical aspects, physical testing. All right. And that's a trust issue. All right, of how much you can get out of an AI model, which is inherently somewhat less precise than a 3D model, and a 3D model being probably more precise than a test because you don't have the environment of the test to take into account, which is not the real usage of the product. But people tend to believe a test in a test cell more than they do a simulation at the end of the day. So I think that's where AI will be part of the strategy to accelerate the de-risking in early stages. But or at least I don't personally think, as head of SIMULIA. I don't think that we're in the next 3 or 5 years where that we'll be close to people saying we don't do any 3D simulations anymore. So when we think about from a business perspective for SIMULIA, to build a model for AI, the easiest way to do it, or the more coherent way to do it to make sure that you understand the quality of the model, is to simulate in 3D information, enough information points to build that model on top of it. Okay, so there's an approach to say I use test data to do it, and it works as well, right? Or I use a mix of test and simulation data. Now that becomes a science in itself of how do I calibrate all of those input data to build a model for it to be coherent so that it's usable. So there are all these industrial aspects. The point I want to make is that there are all these industrial aspects that all the OEMs and larger industry partners are trying to understand when they want to deploy AI. So where it's going to be interesting, and it'll be the differentiation, to come back to one of the questions you had at the beginning. Do we do things differently with startups versus large OEMs? I believe that the deployment of AI in startups might have a different pattern because they don't have a history of data that they've already done in previous projects. Okay, so they might be more keen on having an approach which is more open to say, I provide you data, but I get data from you. So there might be an ecosystem that builds up over time of startups that are ready to share their data, except on kind of specific IP topics, to accelerate the usage of AI. That's still a very open topic in terms of how it goes forward. And I don't think that there's an answer out there on the market today. That's why I say that we're still kind of in the finding phase on the AI topic.
Okay. That's all for today, Sebastien. And thank you so much for your time. Thank you so much for answering all the questions very well. And I thank you again for joining us.